What is up, all my cool cats and kittens? It is Vincent Cashour here to educate you on the physics behind a rainbow. Within rainbows, there are three concepts of physics: the speed of light through different mediums, total internal reflection, and visible light dispersion. Concept number one, the speed of light through different mediums. All light moves at a constant labeled c, which stands for the speed of light, which is equal to 3 times 10 to the 8th meters per second. Now, to put that in humans' perspective, light moves fast. In fact, light is the fastest thing to ever exist. It is the cosmic speed demon. Here's where light gets interesting, however. Light doesn't always move at this constant. For an example, when light passes through materials such as water or glass, which are known as mediums, the speed of light can change and slow down. Concept number two, total internal reflection. Total internal reflection is when the complete reflection of light within a medium goes from the surroundings back into the medium. Now, this occurs when the angle of incidence is greater than the critical angle, and also takes place when between two transparent medias, when both the ray of light in the medium of higher index of refraction approaches the other at an angle of incidence greater than the critical angle. Indexes of refraction depend on wavelength. So, the angle of total internal reflection will vary with wavelength and color. How much light refracted will depend on the wavelength. The shorter the wavelength, the more it bends. And since every color has a different wavelength, each color will be refracted by different amounts. Concept number three, visible light dispersion. Visible light is at the center of the electromagnetic spectrum. Now, this spectrum accounts for all types of energy that travel and spread outward. Visible light is composed of multiple different color components: red, orange, yellow, green, blue, indigo, and violet. When visible light enters a prism, the visible light disperses into its different color components because each color has a different frequency and will bend as it passes through the prism. So when sunlight enters each raindrop, the droplet acts as a prism. So different colors are reflected off the back wall of the droplet. Red has the longest wavelength among the visible colors, so it tends to bend the least, which results in red appearing on the top of the rainbow. Now, violet, on the other hand, has the shortest wavelength, so it tends to bend the most. So violet appears at the bottom of the rainbow. So in conclusion, light's speed changes in different mediums like water, and within each droplet, every color of light is refracted by different amounts. So when sunlight enters the raindrop, the droplet acts as a prism, and different colors are reflected in a pattern with the longest wavelength to the shortest. These colors, however, are reflected in a cone-like pattern, and so those who are very fortunate enough to have seen a rainbow from an airplane in the sky may know that a rainbow is a full circle. But because the observers are only on the ground, we can only see half a circle, or the iconic rainbow arc. Here's my bibliography for all the scientific diagrams used in this presentation. Have a great summer!